everyone. Good evening or good afternoon to everyone. And sorry for my English because I haven't used it for a long time. And today we are talking about how to master recompositions in Compose. But to reach to that point, we need to go through some phases to understand first how Compose works. We'll talk, maybe some of you don't exactly know what Compose is, so we'll do a very quick introduction to it. Then we'll see inside Compose what is recomposition and how recomposition works and why it's important to have it into account. We'll talk about debugging. When we have a problem with Compose and recompositions, we'll see how to find out these problems and how to solve them. And finally, we'll see some common problems and solutions to the recompositions. So first of all, let's get started with how Compose works. And well, this I'm focusing on Compose, of course, but this is something that can apply to any declarative UI system, like for instance, Flutter or React or any Swift UI, because they all follow the same idea. In Compose, which for the ones who don't know, is the declarative UI system implementation for Android and now for Compose multi-platform, for Kotlin multi-platform too. They all follow the same idea. We have a state, and this state is observed by the UI system so that when some part of the state changes, the UI is automatically updated. So for instance, here we have a simple UI state with the value of the user, the value of the password, and a property that provides whether a button is enabled or not to be clicked. So if we, for instance, modify this button enabled and put it to false, automatically the UI system detects this change and updates the UI accordingly. And what's the problem behind this? The problem, or the biggest challenge that we may have here is that we want to update the UI without having to redraw the whole screen, because this previous example was quite simple, but imagine a very complex UI where you have a lot of components and only a small part is updated. It would be quite bad for performance if we update the whole screen only because of a very little change. And this is the whole thing about this presentation and why recompositions matter in this technology, but obviously in any other technology that follows these ideas. But how Jetpack Compose works in particular when compared with other technologies with similar technologies. The first thing is that Jetpack Compose, as I mentioned, is a specific implementation of the interface declarative paradigm. Specifically, was developed for Android, but was developed with the idea that it could be easy to extend, and nowadays is also used for Kotlin multi-platform. So what we are going to talk here applies almost everything to Android, but the ideas of recomposition, etc., are also extensible to Kotlin multi-platform in the case that you want to create multi-platform UIs using Compose. Something that is different from its competitors or its similar technologies is that widgets that we represent in screen are specified as functions in Compose. As opposed to other technologies which use classes, in Compose everything is a function. All the composables, which are the widgets that we use in Compose, that we want to use to draw the UI, are specified by using widgets. And these widgets, in general, are stateless. Stateless means that they don't hold their own state, but the state is provided from the outside. How is the state provided? It's provided by using function arguments. So when we define a composable or use the composables that are provided in the standard APIs, they all receive a set of arguments, and these arguments define how the state, how this composable will be painted in the screen. So when we modify a state, the state is modified outside the widget, and the good thing about this is that this state can be easily shared among different parts of the UI. So the problem we had with XML, that some parts of the UI got desynchronized with the state that we were using, for instance, in the view model, is no longer a problem here because the state is provided from the outside. So we don't have to synchronize the state of the component with the state that is coming from the outside. The thing is that, for instance, this is a simple composable that is representing a list of movies called movies list, which is receiving a title and a list of movies. What we want in compose is that when the state changes, the state, namely the title or the movies change, the UI is redrawn, but otherwise, redrawing should be skipped. And skipping is an important word to keep in mind for what we are going to talk about later. So we want that the parts that are not modified are not redrawn when a small part in our screen needs to be updated because its state has changed. So this is the main issue we need to face, or in particular the compose runtime needs to face when it's redrawing parts of the UI. But to understand how recompositions work and how it can update one part of the screen and not another, we need to also give a look at the three phases of the UI rendering. From the point where we are we are just defining the UI using Kotlin and Compose in our Kotlin files until the point where the UI is rendered in the smartphone of the user. So to go from one point to the other, we go through three phases: the composition phase, the layout phase, and the drawing phase. The composition phase is the first one that happens, which will convert the compose code into a UI tree. Each node in the UI tree will represent more or less one of the composables that we have defined in the code. It's not exactly one by one, but for the sake of simplicity, you can think of it as this. And it's a tree because one composable can contain other composables inside it. For instance, let's say a row, a column, a lazy list, whatever that can hold other composables can have nodes as children of its own node. So the composition, which is the one we are focusing more in this talk, is just this. It looks simple, but it has its complexity. But just think of it as it. We are converting our code into a tree of nodes that represent the UI that we finally want to see in the screen of the phone. The layout phase would be the second one that takes each of these nodes, and each node will ask its children what are their sizes to measure then itself by the measure of the children. So it basically will convert this tree into the positions and the sizes each one of the composables is going to have in the final screen. This is kind of similar to the layout phase that we had, the measure and layout phase that we had in XML. And finally, when we already know where all these composables are positioned in the screen, we would go with the third one, which is the drawing phase. The drawing phase just converts each of the composables. Now that we know where they are positioned in the screen, we just paint the pixels that we are going to see in the screen. So with these three phases, we finish the whole flow from the data, which is the code that we have written, to the rendered UI that the user finally sees. Now that we understand what the three phases are, and especially the composition one, let's dive into what recomposition is. And to see what recomposition is, we first need to see what the composable lifecycle is. When we think about lifecycles in Android, we think of very messy states and difficult to follow, but in Compose, it's quite simple. A composable can enter the composition, recompose 0 or more times, and then leave the composition. It enters the composition, for instance, when a composable is under an if, and the if validates as true, then it enters the composition, which means that it's going to be represented in the UI tree that we saw before as a node in that tree. Then, if the state of that composable, the state that affects that composable changes, then it will recompose the number of times that it needs to reflect these state changes. And finally, let's say, for instance, that the if now validates as false, then this no longer needs to be in the UI tree and would leave the composition. So this is the composable lifecycle, and we are going to focus in the blue square, which is the recomposition and how and when it recomposes. So we said that the composable needs to be recomposed when the state changes. But when is the state changed? The reality is that it's hard to reason on why a composable needs to recompose, because sometimes the algorithm is kind of confusing, and sometimes it can go against our simplest logic, meaning that maybe we haven't changed the state, but for one reason or another, the composable is being recomposed. So thanks to what we are going to see here, we'll understand better when we are changing the state, or when the compose system needs to recompose a composable because of something has changed, or something that compose cannot track needs to be represented in the UI. But yeah, we said that a composable needs to recompose when the state is changed, but what really means that the state is changed? Because maybe we had considered in one thing, but can be that for compose it means a different thing. For this, we need to keep in mind, as we said before, that the skipping concept is important. The stability concept is the other one important concept that we need to get from here today. If a state is stable, compose can skip recompositions. This is also different from some of the alternatives we mentioned before, because many of the UI systems what do is that if, let's say, for instance, a row has a state that has been modified, it will need to recompose and relay out all the children of the composition. But compose is smarter in this situation, and will be able to skip recompositions of the children even if the parent needs to be recomposed. For instance, because the parent has had some states change, but the children are keeping the same state. So if the state of a composable is stable, compose can skip the recompositions of those composables. Okay, so we said that if state is stable, this can happen, but what means that the state is stable? And this is probably the key idea here. A state is stable if this state is a primitive type. For instance, Boolean, int, long, char, double, all the primitive types are stable by default. Then we have strings. Strings are also considered stable. So let's say a composable is receiving a string. If the value of the string doesn't change, the composable doesn't need to be recomposed, even if the parent had to recompose because the parent state did change. All functional types, basically lambdas, are also stable. Lambdas have their own problems with recompositions, but not because of the stability. We'll see later why at the end of this talk. But if a composable receives a lambda, that lambda is considered stable, and because of that, the composable could skip the recomposition if the lambda doesn't change. And then immutable classes using any of the previous types. If I have a data class that has 3 or 4 properties, and all these properties are val, are final, and also the types of those properties are in any of these that we saw before, then the class is considered stable. An example, this data class has 3 properties. One is from a primitive type, the other 2 are strings. So those 3 are considered stable, and they are val, so it means that the data class will be stable too. So if a composable receives a movie, if the movie value doesn't change, the composable can skip the recomposition. When is a state unstable? Well, almost in any other case. We can think that stability is the normal thing, the regular thing in Compose, but it's the other way around. Most of the states that you're probably using right now in Compose are unstable. And that doesn't need to be a problem. We'll talk about a little more about it later. But for instance, collections are not stable. Any composable that receives a collection cannot skip recompositions. So it will be recomposed every time their parents need to be recomposed. Also, mutable classes. If in the previous example we had a class with a var instead of val, that class will not be considered stable, and again, the composable that uses cannot be skippable. And this is important and probably a pain point from many of you. All classes from modules where Compose compiler is not run are also unstable. So if you are using the fanciest modularization in your project, all the projects that are not running the Compose compiler, all the modules that are not running the Compose compiler, the classes that are in those modules are unstable by default. So for instance, let's say that you have your, I don't know, entities or your domain module, and this domain contains all the entities of your project. Those entities will be all unstable. So for instance, an unstable class could be this one because of the description that is var instead of val. And an unstable composable, the one that we show showed at the beginning is also unstable. We have a string which is stable. That's not the problem, but the problem is the second argument, which is a list of movies. Collections are unstable by default. You see here the line highlighted. Okay, so now we know that recomposition can be a problem because maybe many of our composables are being recomposed every time, and we could have the option to not to recompose so many times. The first thing that I wanted to mention about this is that we don't need to be aggressive on the optimization of stability. Why? Because many of these unstable states are not a problem by themselves. Many recompositions are very cheap, and it's more important to focus on other things that being very aggressive with the state, with the stability of our code. Take in mind that in general, compose will work out of the hood without having to be worried about all this. Why is in general not very important? Because in this example that we saw before, for instance, this movies list is unstable, but the composables inside this movies list that are using the movie will be stable because the movie is stable. So even if the movies list doesn't skip the recomposition, probably all the composables inside that movies list will be skippable. And recomposing a composable that with all the compose inside that are stable will be very cheap. So in general, you don't need to worry about this. But let's say that you find a rendering issue or that the UI doesn't go as smooth as we would consider, and we think it could be because of recomposition. This is the point where we should think about debugging. And for that, we have a couple of tools, sorry. The first one would be the layout inspector that probably many of you already know. The layout inspector lets us know what are the composables that are shaping our UI, but also it has some interesting information about the recompositions. In particular, we have a couple of columns. The one that is marked with the red arrow means the number of times that the composable has been recomposed. And the second one, which is the green one, and the colors are chosen because of a reason, is the number of times the recomposition has been skipped, which means that probably the parent needed to be recomposed, but these children didn't need to do it because the state for this child didn't change. So with this, we can detect where is the problem. If you see that there are many recompositions of a composable that shouldn't be recomposing so many times, then you can go inside that composable, and again, if all of the children are recomposing too many times, you may have the problem there. With the layout inspector, you find out where the problem can be. And then you have the stability reports that will help you detect why this is happening. Once we know where it's happening, the why comes with the stability reports. And we have a couple of stability reports. The first one is the classes report, and the other one, the composables report. Both of these reports can be generated in build time, but they aren't generated by default. What we need to do is to add a couple of arguments to the compilation. Don't try to remember this. You will have the slides later. So, but in any case, this what is representing is that we want to enable these reports, the generation of the reports during build time. Once we have this, we will have in the build folder these two reports. The first one, the classes report, will tell us whether our classes are stable or not. Remember, the classes that are inside a module where the compose compiler is enabled. If the compose compiler is not enabled, it will be all unstable by default. So in this case, you can see a class that has all the parameters are stable because they are all or primitive types or strings. And because of that, the class itself is stable. If any of these arguments was var or was unstable, the whole class would be considered as unstable. With this, we can detect whether the problem is on one of the classes. But the order normally should go on the other way around. And we first could check the... Sorry, I forgot this part. This is an example of an unstable class. Unstable, in this case, it's unstable because even if the loading argument is stable, the second one, which is a list of movies, is not stable because of what we said before. Collections are not stable by default. And then we have the composable report that will tell us whether the composables are skippable or not based on the stability of its arguments. If all the arguments are stable, the composable is skippable. So in this case, we have a movie detail which is stable because the movie is a stable class and the modifier is also stable by default. So in this case, unless we change the arguments, the value of the arguments, this composable doesn't need to be recomposed. On the other hand, we have this error text, which is not skippable or unskippable. You can see that here we don't see the skippable prefix. This means that every time the parent composable is recomposed, this needs to be recomposed because compose cannot be sure whether the unstable values have been changed or not. In this case, this is using a throwable, and the throwable class is not stable, even if the modifier is. So this composable will need to recompose every time. Okay, so we have seen what recompositions are, what is a stable value, an unstable one, why composables can be skippable or not. And now we are going to see several problems and several typical problems that we can find in Compose and the possible solutions to it. And we are covering these 7. Thanks to this, we'll also deep dive into some other ideas that can be interesting. So the first one, an unstable class. We said that if the class is not stable, the composable cannot be skipped. It's not skippable. So what we can do, if we are sure that we are not going to do anything tricky with this class is not stable because of the var, what we can do is to add the stable annotation. With this annotation, we are letting Compose know that we want to use this class as an unstable class, a stable class. Yeah. Sorry, a stable class. So from now on, all the composables that use this contact will be skippable if the rest of the arguments are also stable. This can be a problem because if we as programmer go to the name and modify it using the setter, Compose won't detect this change and the UI won't be updated. So when we use this table annotation, now the programmer is in charge of being sure that we are using this state properly. Otherwise, we can see weird errors in the UI. The second one, which is probably more problematic, because this one we could modify our code because it's our code. We could modify it to make it stable instead of using the annotation. But in this second one, we are dealing with external unstable classes. For instance, the collections that we mentioned before, or the classes that are in other modules or third-party libraries. All these classes are unstable by default. The first option that we have to make them stable would be to create a wrapper of these classes. For instance, here we are creating a list wrapper that is pretty specific, but we could create a generic wrapper for collections or for lists, and mark this class, this wrapper, as stable. This is obviously quite convoluted, and the code won't be very nice. So a few versions ago, or a few versions of Compose ago, they gave us another option, which is the recommended one right now, which is the stability config file. We can create a file where we specify the packages and the classes that we consider that are stable, even if the compiler didn't detect them as stable. For instance, we could consider that we are not going to do anything tricky with collections and add the collections to the stability config file. Or also the throwable class, we could add it here, and then the composable that we saw before that wasn't stable, now, sorry, that wasn't skippable, now would be skippable. To configure this stability file, apart from creating the txt where we want, normally maybe the root of the module, we need to also add another compiler argument to specify where this stability config file is held. And with this, all the classes that we define here will be considered stable from this point. I mentioned before that the lambdas had an issue, not because they are not stable, because of this other thing. Lambdas are stable by default, and as we saw, but they are not memoized or remembered by default. What does it mean? We'll see it in an example later, because I think it's easier to understand. But think that when we are rerunning part of the code to do the recomposition, the lambda object will be regenerated again, because in the end, a lambda is represented by an object. And if we run the line again, the object will be created again. It's the same as if we have any kind of variable in Compose that if we want to keep the old value, we need to use remember. With lambdas, it happens the same, even if we don't realize about it. There are some situations when the lambdas are already memoized by default, which is only if the scope is stable. What means that the scope is stable? It means that the properties that we use, or the variables that we use inside the scope of the lambda, are stable. If they are not stable, the lambda won't be remembered by default. For instance, in this example that we have a movie screen with a view model, and then in the movies list with button, we have a couple of lambdas. In this situation, we see that the scope of the lambda is not stable because the view model is unstable. So if the view model is not stable, the lambdas won't be memoized, and every time we run that line, a new lambda will be created, and as in the comparison to check whether the lambda has changed or not, as they are not the same object, the equals will return false, and it will detect that it needs to recompose, even if the content of that lambda is exactly the same. So one of the options would be to make the view model stable, but view models in general are not stable because, for instance, the state flows are not stable. So it would be like lying to the compiler all the time. So we have other alternatives. The first one is to use the function reference instead of the lambda, so that the function reference never changes. So it will return, the equals will return true always when we compare the reference of this function. And the other option is to do the manual memoization by doing a remember of the lambdas. But as you can see, this is quite a boilerplate just to avoid this recomposition. So lambdas are a tricky thing. In general, as I mentioned, you don't have to worry unless you find a problem, but it's there. Lazy column is probably one that you are most aware of, because when you are using this items function, if you don't specify a key, every time the movie's state is changed, all the items inside the lazy column will need to recompose, even if there are probably many of them, or almost all of them, won't be affected by this state change. All the items will need to recompose. So to avoid that, we can add this key. We can add a key to specify to identify each one of the composables. The same we can do with columns, but the columns don't have it implemented by default, so we can use for that a composable called key that will wrap the composable and will identify it with this key. And in that case, now it's able to detect which ones are affected by the state change. Now, there's another one where the state is continually changing. For instance, if we calculate a state from another state that is changing all the time, in this case, the first visible item index, it changes every time we do scroll in the lazy list. But on the other hand, the show scroll to top changes very few times, only when the first visible items moves from 0 to 1 or from 1 to 0. The composable that is using show scroll to top will need to recompose every time the first visible item index changes. And to prevent that, what we can do is to use a derived state of that will create a new state that compose can follow or can observe, and that way the recomposition will happen only when show scroll to top changes. Don't worry about this one, because this one is specified by the Android linter, so you will see a warning if you have this problem. And the final one is one that is a bit complex, and I don't have much time, but in any case, when you have a value that then is used in a modifier, like in this case, the slider value is used to modify the offset of the red ball. The problem here is that every time we change the offset, the composable needs to be recomposed. Because the modifiers, even though we see it here as a state, they, in fact, in the composition phase, they will be parents of the red ball in this case. So every time we modify the modifier, we need to recompose that composable in the UI tree, that node in the UI tree. So this causes a lot of recompositions, especially with a slider that is all the time changing its value. The option is to use lambdas instead of specific values, because the lambdas, what we'll do is to skip the composition phase and go directly into the layout phase, as the lambda doesn't change. because the lambda is a function, and the function can run in the layout phase as many times as it needs. There are several modifiers that can use a lambda instead of a regular value. So check it out, and if you have the lambda option, especially when the state changes so much, I recommend you to use it. And finally, I wanted to talk about the future, because very soon we are going to have the strong skipping mode that is going to solve many of these problems. The strong skipping mode, what does is to allow to have skippable composables with unstable parameters. And how this is going to work? The stable parameters will work exactly the same, will be compared by equals, but the unstable parameters will be compared by reference. If the object is exactly the same, then even if it's unstable, the composable can be skipped, can skip the recomposition. And all lambdas will be memoized or remembered, even with unstable scopes. So the problem that we saw before with the lambdas will disappear quite soon. How soon? Well, we need to use the compose compiler 154 plus, which we already have it, and the compose runtime 1770 plus, which is currently in beta. The 170 is currently in beta, and this option requires an opt-in. They are planning to enable it by default when 170 goes into release. But they are still deciding it, because it's a tricky change, but we can have it very soon in production. So just tell the art, don't do premature optimization. If there's a performance problem, debug using the layout inspector and the stability report, and in the future, use the new recomposition system. And you have here all the bibliography that I've used to prepare this talk. If you want to get deeper, the handles of the social networks, in X and LinkedIn, you already have the slides if you want to check them out. And don't forget to rate the talk. Thank you so much. And if you want to consider any training regarding Android, Compose, architectures, etc., you can scan this QR code where you have all my contact information. And if you want to have training for you or your company, we will be very happy to help. Thank you very much.
Thank you, Antonio. Glad to be here. So we have time for one question, and there is one question. So Babu is asking for modules not using Compose compiler, being unstable, is just adding the Compose compiler for those modules enough to make it stable?
It would be enough. But in general, it's not recommended, because if you add the Compose compiler, it means that you need to add the Android framework, and probably those modules are Kotlin only or Java only, and this is not ideal, because it will impact the building time and all this. So in general, it's preferred to use other alternatives, like in this case, as of now, the stability config file, or in the future, just with the strong skipping mode in the recomposition will be enough. So we have the solution pretty close.
Okay. Thank you very much, Antonio.
Thank you.
Thank you.